Okay, welcome to part 2, example 2. No context in this case. All we have to do is complete a table of values given that y varies partially with x. The last example was talking about direct variation. This one is referring to partial variation. So after we do this example, we can compare the two. We can see what the one term means compared to the other. Table of values is pretty much given. There's a few gaps that are left over. 0 goes to 6, or when x is 0, y is 6. When x is 1, y is 9. When x is 2, we have to figure out what 9 would be. But that's just blank for now. When x is 3, y is 15. Do you see the pattern here? Looks to me like this is basically going up by 3 every time this goes up by 1. So if that's the case, we could expect it to go up by 3 again, and that would bring us to 12. And just to be sure that the pattern is working, from 12 to 15, it's going up by 3 again. And on this side, it's just going up by 1 over and over again. Okay, so I expect the next number after 1, 2, 3, 4, in the x column, we're going to have a 5. And over here, well, what would go next to the 4? Well, I guess it would be 15 plus 3 is 18. But look, we have a problem. If you carry on like that, the next number does go up by 3. But if I went up by 3 again, then this wouldn't be 27, it would be 21. So you see, we're not actually going up by 3 anymore. We're going up by, 9? It's like we skipped 2 steps. So maybe this shouldn't be 5. Maybe we need to rethink that. So I'm going to erase where I wrote the 5 in here and ask yourself, what x value do you think should go here for that number to jump all the way up to 27? So I'm thinking of skip counting by 3s here, 15, 18. I'm going to do 21, and then the next one will be 24, and then 27. So we really should have done 3 steps. If I do 3 steps from here, it's going to be 4, and then 5, and then 6, and then finally 7. So I think this number should actually be 7, and that would correspond with 27. Let's do part B here. Is we're supposed to graph it. Oh no, sorry. Before we graph it, we're supposed to identify the initial value of y. The initial value of y. And the constant of variation from the completed table. So the initial value is here. Here's y. The first value is 6. And it's important that that value corresponds to an x value of 0. So I'm going to write here initial value y equals 0. Better than y equals 0, actually. I'm going to introduce another variable. You might be wondering why I would choose this letter, but it's just kind of a convention. But for our initial value, we usually use the letter b, and that will start to become familiar with time. So let's just say the initial value is b equals 0. And then it also asks us what the constant of variation is. Well, remember, that's the rate of change. That's how fast is it increasing. With our driving to Deep River, Ontario question, example 1, it was 120 kilometers per hour. So every time this goes up by 1, it would have gone up by 120 kilometers. In this case, it's going up by 3. So the constant of variation it's basically our rate of change. We're going to call that m. And so I'm going to say that the rate of change in this case is 3. Okay, it's going up by 3 every time these go up by 1. When this goes up by 9, it's because that went up by 3. So 3 times 3 is 9. Hopefully that makes some sense. And then we're supposed to graph it in part C here. So for our graph, we're basically going to graph all these points, 0, 6, means we go over 0 and up 6, and that's our first point. And 1, 9 means we go over to 1 and up to 9, and I think that point's about here. I don't have a nice grid on mine like you have on yours, but that looks pretty good. 2, 12 would be something like this. I'm already not liking that, but anyway. 3, 15 would be something like this. 4, 18 over to 4 up to 18, something like this. And then 7, 27, I have to go all the way across to 7 and then all the way up to 27. So I'm going to say that's going to be a point somewhere around here. Now, if we do it correctly, this should be a linear relationship, which means it should basically be a straight line that connects all of these dots. Maybe some of those dots aren't graphed perfectly on mine. Hopefully, if you've graphed it a little bit more carefully with the nice grid you have here, hopefully your dots will line up a bit more perfectly than mine did. I think the dot that looks out of place on my graph is actually this one, so I'm going to graph it. Oh, I see, my spacing is off on my grid. Anyway, not bad, not bad. So there's our table of values. We know our initial value is 0. Our constant of variation is 3, and the graph looks like this. And you can see the initial value. Anybody catch me on this mistake? Whoa, do you see the mistake? I just saw it now. I didn't see it when I wrote it. I wrote b equals 0. What should I have written? The initial value isn't 0. The initial value is the y value when x is 0. What I should have written was b equals 6. All right, what do you think? Should I press stop and go back and re-record? Hopefully you guys can handle it. Part D, describe the graph. Oh, we did a whole lot of this in chapter 2, didn't we? How would you describe that graph? Well, I would describe this graph as being linear because it follows, all the points lie exactly on a straight line. So it's linear. In math, linear means straight line. And the other part is it going up, or is it going down, or is it horizontal? And in this case, it's distinctly going up. So what's the word we use for that? Not going up, increasing. So it's linear and increasing. That would be my description of this graph. If it was curved, I would call it nonlinear. Since it's straight, call it linear. And since it's going up, we'll call it increasing. That's about it. That's example 2. But I just want to point out that what we did this time was considered a partial variation, and how it's different from example 1 has everything to do with this initial value here. When the initial value is 0, like it was in example 1, when the initial value is 0, it means that you have a direct relationship. If you know how much time you spent driving, you know exactly how far you've driven. You just multiply by 120. But in this case, we have to do more than just multiply, because if you were just to multiply by 3, then you would get 0 goes with 0 and 1 goes with 3. That's not the way this one works. In fact, it starts with an initial value of 6. We have to add that on. Let me go back and see here. Oh, I missed in part B. It said we're supposed to write an equation relating y and x in this form. So we know what this number is and what this number is. I'm going to give you the equation, and we're going to see if we'll see soon why it is that it works. Our equation should be in the form y equals m times x plus b. In this case, our m is going to be 3, so I'm going to write y equals 3 times x plus 6. And that's the equation in this form. It's a little bit different from the equation we did in example 1, because we're not just multiplying, we're also adding. And it's partially related because it's not, the y is not directly related to x, which it would be if I was just multiplying a number by x, but it's partially related to x, and it's partially related to this constant. Does that see where the partial comes from? Y is partially related to x, and it's partially related to the number 6. So this is a partial relationship. On the graph, you can tell it's a partial relationship because it starts at 0, 6. You go over 0 and up 6. If it were a direct relationship, it would start down here at 0, 0. We call it the origin of the graph. A direct relationship would start there. A partial relationship will start anywhere else. The fact that we have an initial value of 6 instead of 0, 0 tells you that this is partial. Does that make sense? So maybe now when I go back and describe the graph, I might want to add the fact that it's linear and increasing. And it doesn't start at 0, 0 at the origin. That's important. Okay, it starts here somewhere higher or lower in some cases from the origin. We have, I think, a definition box which says partial variation is a relationship between two variables in which the dependent variable is the sum of a constant number and a multiple of the independent variable. So it's partially related to the independent variable. And so that hopefully will help us make sense of it. Try another one.